All right, everyone, welcome back. Back-to-back videos by Dr. Sears here at Bluefield State University. Today we're going to be talking about, the second video of today, we're going to be talking about roof support and how it pertains to the MIET 392 class project. Okay. So, in real life, we would have a number of things at our disposal. We'd have historic data. We'd have various roof support sort of selection techniques that exist out there. You can look at suspension design, beam building, keying of strata, that sort of thing. And we will, like I've mentioned, be deep diving into that topic next semester in the ground control class. But for now, for this project, I want you to know that there is a software out there that does aid in determining what would be a minimum type of roof support based on a number of input parameters that are available to us. So, with our sandstone top, that we've talked about in this mine for our project, using the CMRR estimator, you get a 55 for sandstone in this case. And on our previous presentations, we were talking about reducing that a little bit because of the likely fracturing of that when it was a multiple seam scenario. But given that it's not now, I went ahead and set that at 55 just to see what we would get here. Our depth of cover is 1,000 feet, basically for all of the panels, right? Unit weight of rock, 162. We'll keep that to default value. And then I added in some of the diagonals as 64 feet, and that may be a hair low, maybe 65 on those, given that, we're looking at 20-foot wide entries here. There is some information on the sum of the diagonals in the help file that you can look at, and it gives you, estimates for what those are based on the entry width. Okay, so also our analysis options. We have selected primary roof bolts and secondary support in the intersections. Only in this case, given that we have significantly strong roof. If we did not, or if there was undermining like we had originally suggested, you would probably also want to analyze secondary supports in the entries as well. But in this case, we've limited it to the intersections. So, stability factor in this case, a 1 is sort of the cutoff there. And so I put in, there's a suggested minimum bolt length, 4.5 feet. I used a 5-foot bolt to exceed that, and then I just put in standard 4 bolts per row, 4-foot row spacing, and then selected number 6 grade 60 rebar. I just guessed at those numbers, and so it's suggested some of the diagonals was 67 feet. So you could have a pretty wide intersection here because the roof conditions are so good. But like I said, it's probably going to be in the less than that, 64, 65 range. And then when you look at this P-sub value, this is a value that's based on the number of bolts, the length of bolts, the diameter and grade of the bolts, which takes into account the strength of the bolts, that sort of thing. And that calculation is all in the help file as well. But so we've exceeded our suggested value by just a small amount. So this would be just minimum bolt design for this particular mine based on this software package, like I said, which is an empirical, model that we will talk about in the future. But once again, we're driving the race car, before we get under the hood, so to speak. There is a standard table of bolts that you can select from. Of course, I chose grade 60 rebar, but there are other grades, grade 40. There are other diameters as well, right? Number 5 is available in here. There are very few coal mines that I know of that still use number 5 rebar. In fact, there may be none now, for all I know. But generally speaking, when I was in industry, the number 6 rebar 3/4 inch was the most widely used. I don't know that that's still the case. A lot of the mines, back in that time, we were considering trying to drill like an inch and a 32nd hole or an inch and an 1/8 hole or something like that to install a 7/8 bolt, 7/8 inch bolt, a number 7 rebar, right? That's what we were originally going to, try to do. And what has happened, I'd have seen inch and a 32nd roof bits out there, but a lot of mines now are going to the 0.804 diameter rebar. This is just a general trend over time of going to stronger bolts. It does help, I know I'm kind of droning on and on about this, but in some situations where you have a need for more roof support and a stiffer roof beam, you might install 6 3/4 bolts per row, like number 6 grade 60 bolts. However, you can get a similar strength and stiffness if you would install 4 7/8 or 0.804 bolts instead. So you're putting in less bolts overall. This works well if you have a roof that's competent enough to not require the extra sort of skin protection that you're getting from more bolts and more plates and that sort of thing. But there's a number of different supports that you could put in here and get valid answers for, but this is would be a base level sort of minimum. Okay. When we skip over to the secondary support in the intersections, I have made some assumptions for rock load height here and for roof fall angle. Okay. In the help file, there is some guidance on this. That's where I selected the 45-degree roof fall angle. And then for the rock load height, I changed this around quite a bit. So what you're really doing is calculating sort of this dead weight load. But with the fall angle, okay, once you get significantly like above 10 feet in this case, the rock load doesn't increase all that much. Okay, so you can put in 20 feet, and I don't think it exceeds this 156 tons. So I chose that as the rock load height. It is a reasonable number. A lot of mines are putting in anywhere from 8 to 12 foot cable bolts in the intersections. I don't think there are that many that are using 16s, but typically that 10 foot value, 12. And then for the support system, I did select cable bolts. You can select additional roof bolts, right? So say you just want to put in some 8 foot rebar into the intersection. It's an option in the program. Truss bolts are also an option, which is generally kind of one of my least favorite support options. But they do have their place in the roof support world. Okay, they do have a purpose. So for me, I chose cable bolts. There's a 12-foot length that I put in here. Generally speaking, you want 4 feet above the roof fall, potential height. But I just put in 12. So let's see what that gives us. 0.7 diameter cables. There are both 0.6s and 0.7s. Generally speaking, I highly recommend 0.7s. They're much stronger and just perform so much better than the 0.6s generally do. And when you're considering, just like dead load weight, right? If you put in couple 0.6s, every other row, right? So you're putting them in basically every 8 feet. When you think about how much rock that can actually support, it's not all that much. It's like 3.5 feet or something, 4 feet of rock. That's it. So to use 0.6s, then a lot of times you got to switch down to every row, which may or may not be more than what you need. So generally speaking, I go with 0.7s, and then I put the old star pattern, 5 bolts per intersection in here, and it does give us a usable stability factor, 1.14. Our support capacity does exceed the rock load, okay, and that's probably why 5 cable bolts in the intersection has worked for the vast majority of intersections that have been retreat mined, okay. It's a relatively few number of cases where it didn't work, and then you need the 6 bolts, which I said is most common now probably, and what I would recommend. I would add 6 bolts here instead of 5, but I'm just showing that this does meet sort of the minimum. I say requirement, but this is not requirement. Okay, it meets a minimum sort of guideline on what you might need. You can also see all of this information in the results page. Okay, our span checked out because I put in 64. Roof bolt length is okay, right? It's longer than the minimum suggested. Our P sup is okay. And then our intersection support for the cables, right, is also okay. So this has been a presentation on how to use the analysis of mine roof support AMRS software as it pertains to our newly revised underground mining class project. Given that the parameters for the project are the same throughout the district that you'll be designing, and due to the nature of the ridge line that runs through there, you really only need this one calculation for the entirety of the project for roof control purposes. Like I said, this isn't the final answer, but it's the initial answer to the question of what kind of support should I be looking at as far as roof bolts go, and standing support as well. You can use the program for that too. So with that, we'll see you next time.